Here we're asked to find the rational zeros of each polynomial, then write each function in factored form. So the first thing that we have to do is use the rational root theorem to find all of the possible rational roots. And basically with that, we have to find all of the factors of our constant, which the factors of 8 are 1, 2, 4, and 8. And don't forget that's positive or negative any of those numbers. Now I have to use that over the factors of our leading coefficient, which is just 1, again, plus or minus. So basically we take each of these numbers, 1, 2, 4, and 8, and put it over 1, which doesn't actually change the value. So all of our possible rational roots are positive or negative, 1, 2, 4, and 8. So what that means is we can use synthetic substitution to check if these are, in fact, roots of this equation. So I'm going to start just in order. I'm going to start with positive 1. So what I'm doing here is I'm now putting the coefficients here into synthetic substitution. I'm going to bring down this 1. 1 times 1 is positive 1. Negative 1 plus 1 is 0. 1 times 0 is 0. Negative 10 plus 0 is negative 10. And 1 times negative 10 is negative 10. Add these two to get negative 18. Because this is not 0, I know positive 1 is not a root. Now I'm going to try this with negative 1. Same idea. 1, negative 1, negative 10, negative 8. I'm going to go ahead and change colors here so that we can differentiate here. So bring down the 1. Negative 1 times 1 is negative 1. Gives me negative 2. Negative 1 times negative 2 is positive 2. Add these to get negative 8. Negative 1 times negative 8 is positive 8. Add them together and I get 0. So because I got 0, that tells me that negative 1 is in fact a root of this equation here. And so what that means is that because if I plug in negative 1 into x plus 1, I can factor out x plus 1 from this equation that we started with. What's left after factoring out x plus 1 is what we were left with when synthetic substitution. So in this one here, it is 1x squared minus 2x minus 8, because that is what we were left with here. So now all I have to do is continue looking for numbers from my possible roots using this factored form here. So now I'm going to go ahead and use positive 2. I'm going to go ahead and change colors here again. So I'm going to use positive 2, and I'm just going to use this equation now because I'm just factoring this part here. So it's going to be positive 1, negative 2, and negative 8. So bringing down the 1, 2 times 1 is 2. Add these together, get 0. 2 times 0 is 0. Add these together. Okay, it is not 0, so positive 2 is not a root. Let's try, I'm going to go ahead and use green here. So now I'm going to try negative 2. I know it's getting a little bit cramped, but again, I'm going to use this here. I get 1, negative 2, and negative 8. Negative 2 times 1 is negative 2. Add these together to get negative 4. Negative 2 times negative 4 is positive 8. Add them together and I get 0, which is good. Tells me that negative 2 is another 0. So far I have a 0 of negative 2 and a 0 of negative 1. Now I can factor that out again. So what I'm left with here, let's go with blue. Again, I'm going to keep this x plus 1, so I'm going to put this over here to give us a little bit more space. Then x plus 2, because I know negative 2 is a 0, so x plus 2 is definitely in our equation. And what we're left with is just x minus 4, because that's what we're left with here. Now we are completely factored, so this is the function in factored form, and my zeros here are negative 1, negative 2, and then what I was left with was x minus 4, so that tells me that 4 is my final 0. So there are my zeros and my polynomial in factored form.